Okay, welcome to the empirical rule. This is from a workbook, and you'll see it's the first question we're looking at, question 1. Now, the empirical rule, just to break it down, we're going to talk about the percentage underneath this bell curve, which is the area underneath it. Now, the first thing to always point out, the total area under this bell curve, if you shade the whole thing in, is 100%. Or, as a probability, it'd be 1. So the whole area is 1 as a probability. Now, we're going to look at 68% is within 1 standard deviation of the mean. So here's the mean, mu. And if we look at 1 standard deviation from the mean, which is here and here, that area in here, 1 standard deviation from the mean either side, minus plus, is going to be 68% or 0.68 as a probability. So 68% of a population will be in this category. Now, if we look at the next one, which is 2 standard deviations, so there's mu minus a standard deviation, 2 standard deviations, minus 2 standard deviations from the mean, that's from here to here. That area is going to be 95. 2 standard deviations, 95%. That's all 95%. And then the third area, which is 99.7, that's from 3 standard deviations from the mean. 3 standard deviations, that's this whole area here. And that whole area here is going to be 99.7% or 0.997 as a probability. Now, we're going to go back and look at it again a bit differently. This time, I'm going to look at just breaking this up. We can break this up and we're going to do this question. So the first thing I'm going to do is the data set has a mean of 5. So this is 5. And we're going to have a standard deviation of 1. So we're adding on 1 each time. So we're going to be 6, then 2 standard deviations is 7, 8. And we stop with 3 standard deviations. This is going to be 4, 3, 2. Now I'm going to split this up. And I'm going to split it up into the lines that we've seen already. And this is going to be my first area that I'm going to look at. 1 standard deviation from the mean, which is here and here. And I'm going to draw a line straight down the middle, where the mean is. Now when we look at this, and you can remember these numbers if you want, it will always be the same numbers when we're estimating percentages of probability with a normal distribution. This whole area here, that is 68%. Now what we can do is we can call this 34% and 34% here, because those two numbers add up to 68%. 68 divided by 2 is 34. And this here is symmetrical, so these two areas are the same size. And if the whole thing is 68, and half of it is going to be 34. So we're going to write that down. 34%, and 34% here too. Now we can go another standard deviation. We'll do 2 standard deviations from the mean. Now this whole bit here, that is going to be 95%. Now if you want to find this area and this area, you just get the 95% and we take away the 68%. And we're left then with this and this area added up in total. And if we divide that answer by 2, then we're going to get these individual areas for here and here. And if you do that, you will get the number 13.5. 13.5%. 13.5. And the last one here, the same type of thing again. If we take this whole area underneath here to 3 standard deviations, 3 standard deviations. From here to here, that whole area is going to be 99.7. And if we take away like 95 from it, take away the 95%, and divide by 2, we'll end up with these two areas at between the second and third standard deviations. And they're going to give me a number of, I'm going to put that in there. In there, that's going to be a number of 2.35%. Again, 2.35%. And the very last bit, the very end tails bit of it, where it goes over, that's the leftover. It's out of 100%. So it's 0.15% and 0.15% here. And that's the total area. The total area here under this curve will add up to 100%. So the first question here, once it's labelled, and every single normal distribution curve when you label it, with standard deviations going up, 3 and 3 down, will have these exact same percentages for these areas in between them. So the first thing we want to look at here is this question here. The probability of having between 4 and 6. So the area under the curve of 4 and 6. There are two different type of questions here. The area under the curve and the probability of having between 4 and 6. It's a P here for probability. So between 4 and 6. Here's number 4. And here's number 6. So the area under this, the area between 4 and 6 is going to be 68%. Because it's this 34 plus this 34, which is 68%. Now, here you've got the next thing, which is the probability of having between 4 and 6. Now, that is a decimal between 0 and 1, because we're talking about probability. This P stands for the probability of picking somebody between 4 and 6 here. And all you do is you change this percentage into a decimal. And you divide by 100, because percentages out of 100, 0.68. 68 over 100, just divided by 100. So we're looking at here, 0.68. And that's that answer done. 2 answers. The next one here is the probability of having x is greater or equal to 5 and the area greater than 5. So area greater than 5, here's 5. And that's exactly half of it, isn't it? It's half the whole thing. So that's 50% of it. So the area is 50% of the area, or as a probability, 0.5. The next one is between 0 and, so I'll just move that over, between 5 and 6. Between 5 and 6. So we'll do the same thing again. Here's 5, here's 6, and I've got it labelled already. It's 34. It's 34%. So I'm going to say that is going to be the area under this is 34%. And the probability of having between 5 and 6 is going to be 0.34. Next one is going to be 3 and 7. So the probability of having between 3x and 7 is going to be, we look up here, and we've got 3 and 7. That's this whole area here. And that's 2 standard deviations. And we know what that is already because we're told up here, 2 standard deviations, 95%. Or you can add those percentages. So that's 0.95, or as an area, we'd say 95%. Next one is between 3 and 6 standard deviations. Well, not 3 and 6, between the numbers 3 and 6. And we're going to look at that. Here's 3, here's 6. So we have to add these up, these numbers up. That's my area here. So we'll go to my calculator. And we'll go in here. And I'll just clear this. So we're going to 13.5. That's this first one here. Then I'm going to add up this and this between 3 and 6. Plus 34 plus 34, and that equals 81.5, as you can see in the calculator on the right. So that's going to be 0.815, or is an area 81.5%. Now greater than 7. Greater than 7. So the probability that x is greater or 7, greater or equal to 7, we're going to go up here and we can see this is greater than 7. Here we have it here. There's 7, greater than 7 up here. That's these two numbers added up. So we can do that in the calculator, or we can do it by hand, and you get 2.5. 2.5. So that equals 0.25 or 2.5%. Now I've got between 2 and 6. Between 2 and 6. So we go back up here and we look between 2 and 6, which is here. So we just add up these numbers, this, and this. We're going to add those up. Those numbers are going to add up. We're actually going to highlight them if that's okay with you. Highlight them. So the numbers I'm looking at is this number. So it's this, and this, between 2 and 6. So we'll look at that and we'll add those numbers up. I'll actually do it right now in front of the calculator. So it's 2.35 plus 13.5 plus 34 plus 34, and that equals 83.85%. So we'll go here, and I say the area here is 83.85%. And the probability of selecting between 2 and 6 inclusive is 0.8385. And that's this done. Thank you very much for watching.